Hello, my name is Nadia Vinogradova-Schiffer. I direct Ocean Physics program at NASA headquarters, Science Mission Directorate. I'm also a SWOT program scientist. We're launching a new mission. It is called SWOT. And today I would like to share with you why we, NASA scientists, are buzzing with excitement and anticipation about SWOT launch later this year. So SWOT is a water mission. It will track nearly all surface water on planet Earth. Water that we drink, water that we use for crops, water that fuels our weather events like storms and rain, water that controls Earth energy, water that softens our climate, or water that rises from the seas, takes over our land, and changes our coastline. All this water will be seen by SWOT in one mission for the first time almost entirely over the whole globe. And by the whole globe, I mean both the oceans, where water originates, and land, where the water sinks, fills our lakes and rivers and reservoirs, and everything in between, the coasts, where water returns back from land to the ocean, completing and perpetuating our water cycle. So today I thought, let's pretend that we're flying with a SWOT satellite over the globe and trace this cycle of water and see what we can learn about Earth energy, water, and climate along the way. So I'll start with the water source or water origin story, how my comic nerds at home will tell you. All water originates in the ocean. Ocean supplies a tremendous amount of moisture. Millions of cubic meters per second are leaving the ocean. Lucky for us, most of this moisture comes back to the ocean as rain and precipitation and snow, mostly in the tropics and high latitudes, as you see on this white spots on this animation. But some of it does make its way to land. And we humans and ecosystems, we rely on this steady supply of this moisture from the ocean to land. And any deviations from this norm would be felt on land. We would have droughts if the ocean supply of moisture is interrupted, or we will have floods if the supplies becomes too large. So as a global mission, SWOT global view would allow us to monitor the cycle of water and its disruption as a complete process, both in terms of the supply from the ocean as well as demand and usage of water on land. Essentially, SWOT will give us this missing connection between the water sources and water sinks, between the water movement and water storage, between water supply and water demand, between ocean and land. Yeah, we're excited. So what happens when water moves? Let's talk a little bit about it. When water moves, it moves and transfers a bunch of properties with it. Properties like heat or energy, carbon, nutrients, oxygen, everything that we call fundamental cycles of the Earth climate system. And this cycling, this transfer of these fundamental properties, largely determined by the upper ocean flow, something that we would be able to derive from SWOT. And one of the most exciting part of that is that we will see the water movement with unprecedented clarity, at a higher definition than ever before, like 10x better than what we observe now. It's like going from your old VHS tape to a 4K screen. Pretty cool. So why high definition matters? Besides that, of course, nobody likes to look at blurry pictures, but why does it matter for Earth science? Well, it turns out it's pretty important for major Earth climate processes. I'll give you one example, Earth energetics. What we will learn from conventional altimetry that NASA and partners been flying for 3 decades by now is that ocean ability to move and store heat is what actually spared humanity from experiencing a full impact of global warming until now. And the biggest question in climate science today is, for how long? What is the turning point when the ocean slows down this absorption of heat and starts releasing this energy back in the atmosphere where it came from? For context, for example, if oceans were to release all this accumulated extra heat, our low atmosphere would heat up by additional 36 degrees Celsius. That's a whooping almost 100 degrees Fahrenheit. Obviously, such release, instantaneous release, is not physically possible, but the gradual release is. So how gradual it will be? How fast this process will progress? This is where SWOT comes in, and we hope would answer this critical climate question of our time. And you can imagine that even small release of energy, giving the oceans huge thermal capacity, that would lead to large and uncomfortable warming tendency in the atmosphere. So viewing at high definition, viewing ocean energetics from large to small is what will allow us to see the Earth energetic in their completeness and improve our prediction of the future Earth energy budget, whatever it might come. In fact, what do we know about small-scale energy transport and exchange today? Well, our climate models, including one such as NASA ECHO, they say that small energetics are pretty prominent players in the Earth climate system. Some studies suggest that ocean eddies and turbulence, they pump up more heat in and out of the atmosphere than heating from the greenhouse effect. That's an impressive statement. Is it true? Our models are correct? Well, we've never observed it until SWOT over the globe. SWOT would be our first observational evidence of such an effect, our reality check whether our current understanding of the climate system is correct, our understanding and prediction of the fundamental cycles of energy, heat, moisture, carbon. That's a big ask. That's a big deal. No wonder we're buzzing with excitement. And also think about it. If the turbulence turns out to be that missing piece that helps us better predict the future, that would also become a paradigm shift in the requirement for our future observing platforms. Because whatever NASA decides to observe next, it's better be prepared to observe and resolve the climate of the future. So again, all eyes are on SWOT to demonstrate what would be our next standard in ocean observing would be. All right, so let's keep flying from ocean to land, from sources to sink, and come back to land. So let's see what SWOT can do for us there. So even though land hydrology takes up less than 10% of the water cycle, this is all Earth available water, as we call it, water that we use in agriculture, in industry, and drinking. This all available water, as we call it, it's stored in reservoirs on land, and SWOT would measure surface elevation and storage in millions of lakes and rivers, almost everywhere in the globe, some places for the first time. This worldwide view of land water storage is a phenomenal characteristic of the mission. It's just hard to overstate. With SWOT, we will know where this water is now, where it is going, and where it will be tomorrow. With SWOT, we will be able to answer if a population have enough water to survive or has too much water that damage their livelihoods. This information is key to start addressing water equity issues across the globe. This is also key to prepare for a new climate. As the planet continues to warm and the water cycle continues to change, some land reservoirs would be oversupplied through ocean moisture, through rain, river floods, or increased surface runoff that contaminates our drinking waters, while other land reservoirs would get replenished fast enough and causes deficit in our water in industry and agriculture. SWOT data would be critical to plan for the future like that. It will also help us address issues in environmental and climate justice, as well as make decisions in our daily life. We truly anticipate that SWOT land hydrology data would help water resource management, food and disaster management, a variety of water industries such as hydropower, hydraulics, navigation, or provide information to those who study water quality or do a service of the ecosystems. In fact, our science teams already working with external users through a program that is called SWOT Early Adopters. They too want to be ready to use SWOT data on day one, and they too are buzzing with excitement. And I hope that you begin to understand why. All right, so flying further from land to ocean through the coast. When water comes back, this from land to the ocean, this high definition property of SWOT will give us this unique and new look of coastal environments. That means never before scenes of our estuaries, river deltas, watersheds, as well as coastal environments and sea level that affects half of the world population, and coast is where home of our major economic and industrial energy center. So again, why do we need a high resolution and close to the coast sea level information? Well, one of the example I'd like to leave you with is to improve our projection of the future sea level rise. Here's on this plot, you're looking at the NASA's first projection with an example of Washington, D.C. And one thing you can notice is the divergence of our futures, depending on what choices we make today. The only way to know what future we are on is to observe where we are headed in real time, to have real-time observations in order to demonstrate which trajectory we are most likely to follow in order for us to prepare for this most likely future. So bringing coasts and the sea level and hotspot of sea level right into focus, this is where SWOT comes in. I call it SWOT goggles, where they really bring the high definition and high resolution coastal environment into focus. So all of this unprecedented information from science interferometry means unprecedented amount of data volume. Even with SWOT smart hybrid approach of onboard processing of some of the information, NASA was looking at tripling the amount of data volume streams with SWOT. And we're not talking about small numbers. So essentially, SWOT was the catalyst for NASA to rethink the work with large data and move the agency towards the cloud. That moves towards the cloud was additional push for us to broaden our definition of open science. Which is both technological shift, but also a cultural shift for our community and users. And with SWOT Observatory many firsts, both technological and scientific, we felt that it was a proud moment for our community to lead the way towards this new way of doing business of science, science of sharing and cooperation for mutual benefit, science where you build an inclusive community where collaboration is more accessible and fun. So SWOT Science Team was paving the way with this transition, and I'm very proud of this team accomplishment. And I must say, there is no better way to start 2023, the year of open science at NASA, than kicking it off with SWOT launch later this year. And blazing a trail for open science, or testing new observing technologies, and in general pushing frontiers of scientific knowledge, is also and no better way to do it as with long-standing partners, like our partners at CNES. We started our collaboration 3 decades ago with the launch of the first altimetry mission, Topics Poseidon, and now we're launching SWOT with our partners at CNES, taking altimetry to a new level, to its next orbit. So when we look back at this 30 years of collaboration, we reflect on our friendship, we celebrate our commitment to Earth and ocean observing, and doing it with a partner like CNES gives you a certain level of comfort. It's like working with somebody you grew up with, somebody that you know very well. It's always good to do new tricks with old friends. So finally, I want to give a shout out to our SWOT science team. We are an international and diverse group of scientists. We both work on individual science investigations. We also work as a group on thematic challenges. We've planned a dozen of exciting field campaigns to take advantage of the SWOT fast daily repeat cycle. We are also connecting with external using and industry management and policymakers. Being a NASA scientist is a competitive process. We just recompeted the team a couple of years ago and have a lot of new blood and a lot of early career scientists. But some of our members worked on SWOT for 20 years or more. That is the people that took us all the way from wild dreams to reality, and we're extremely grateful to them. In fact, I asked the team, what excites you about SWOT the most? And here's what they sent me. Enjoy and hear it from them directly.
We are in a very mature phase for SWOT because we have been working on this for more than a decade, and that the science community is really excited about the preparation for SWOT. We have learned so much just from the preparation of what we hope to see, and that the science community is really excited.
We have some really accurate satellite altimeters, but they're like a point measurement going along on the satellite track. SWOT will be making two-dimensional measurements, kind of mapping out a picture of the ocean surface as it goes along.
So fundamentally, SWOT measures two things. It measures the elevation of water surfaces in rivers, lakes, and oceans around the world. And it measures the extent of them. It measures how big they are and how that changes over time.
Now, SWOT will not measure the very small particles. It will not measure the sub-mesoscale, but it will get at this very, very interesting window between 15 and 150 kilometers that we are not able to observe right now. And so I'm really excited about just seeing what the ocean looks like on those scales. We just don't know. We've had these glimpses, and now we'll be able to see what happens over a season, what happens in the regions that no one's bothered to do a field campaign. And I think that's the thing that I'm most excited about.
And I'm really excited about being able to image the ocean surface to see its internal tides more clearly. And then I'm also really excited about the higher latitude observations of SWOT. I think we'll just learn so much about the tides in the Arctic and around Antarctica that we haven't been able to learn from previous missions.
There are still big parts of the world where either because of a lack of infrastructure or a lack of sort of the right political environment, we're really blind to how the amount of water in rivers is changing over time. And SWOT is, for the first time, really from space, going to show us how much water is flowing through the world's river. We've been trying to do this with other satellites for 30 years at least, and we've made some progress, but nothing like we're going to be able to do with SWOT. It's just a complete game changer.
SWOT will truly be a revolution for the understanding of how much water flows within the Earth's rivers globally, because it's a first of its kind measurement. It's really the first mission that is specifically designed to measure the Earth's rivers, among other very important things. But it will provide global observations in a way that is unified, same instrument, same measurement everywhere, and devoid of political bias.
So we are prepared. I think we are well prepared, but we're also open that there may be new opportunities and perhaps new challenges that come out of this observation. But I think it's something that the whole ocean community that is working on small-scale structures is really, really excited to see what will come out from SWOT.
All right, so here you have it. NASA's Earth Next mission is in search for water on planet Earth. Thank you for watching, and go SWOT. Bye for now.